Hi everyone, I'm Nick. I'm a lead instructor at Nebula Academy, and today we're going to be taking a look at the Raspberry Pi and how it can be integrated into classrooms.
All right, fantastic. Thanks for joining me, Nick. So Raspberry Pis traditionally have been very much a hobbyist kind of thing. So they've been out a long time. This is actually our Raspberry Pi 4. So different iterations out there. Again, cost pricing range for these vary depending on what you buy with them, what kind of kits you buy with them. We're going to just show some real simple stuff today just to introduce educators. And again, I want to stress this, when we think about those who might be interested in this stuff, it's educators looking to help support students. In this case, probably high school and up. Middle school, again, you got to know your students and what they're capable of doing or how challenged they'd like to be. And because certainly when you want to introduce this stuff, you don't want it to be so challenging that they get frustrated, right? So maybe this is something you build upon with other type of smaller tech, maybe like the microbits, and you move on to this later on when they've outgrown some things. And that's when Raspberry Pi kind of plays well with that. But from a summer program, great way to introduce some really project-based learning. Educator, again, high school, upper middle school, and then for those independent moms and dads or homeschooling, great way to really teach a lot of really amazing electronics and circuitry and really, physics, science. There's just so much stuff that you could teach with this.
Yeah.
Even biology, right?
The Raspberry Pi itself is a bit like, if you think about it like an art classroom, right? The Raspberry Pi is just like your canvas or like the paintbrush. You can't do anything with it by itself. You need to set it up, and it's got all these cool things, really cool things that you can do with it, but it's not going to be as simple as your drones or your microbits.
Yeah,
right?
So from an educator knowledge-based perspective, or anybody who's using it, got a little bit of pre-work that you got to do to get ready for this stuff, right? You got to have some concepts and understanding, unless you're one of those who's brave and is willing to just kind of put it out on the table with the kids and say, have at it.
Yeah, absolutely.
I love doing that because it's amazing what they'll do with it when you give them all this tech and you explain to them what it does and how it works and give them the tools and resources and then see what they do. And that's really, from a parenting thing, I encourage that. And then, when they get frustrated, teaching them how to figure out how to solve the problem or what wall they've hit, how to overcome that. And that's really using tech skills like searching the internet, watching YouTube videos, right? Finding information on the web. Those are skills they need to learn and learn really well, and what sites are really good information, which ones are not maybe so good. And they can use all of these skills together and then combining it with something to make, right? Some problem that they're solving.
Yeah. And to speak to the Raspberry Pi itself, it's got a lot of the components that you traditionally see on a computer, right? So it's got its own processor, it's got a USB-C, it's got HDMI ports, it's got traditional USBs, it's got an Ethernet port, and then it's got its connectors so it can connect to like a breadboard or something like that.
Yeah, the breadboard really is key, and the breadboards come in different sizes, and they'll have different options with them, and there's other expansion cards too that you can buy with them that do other things. You can introduce sensors to them. There's lots of stuff on the market. Again, if you're a real geeky kind of teacher and you want to get into sensors, you can really kind of go nuts with this.
Yeah, so, and the Raspberry Pi itself, you can save money by going back a version. It's not necessarily what I would recommend. But you can save money by getting lower RAM. You can get higher RAM. So I think they come from either 4 to 8 or 2 to 8. Either way, gigabytes, right? So an 8 gigabyte computer is really what it is. It's a tiny little simplified computer that you can stick what you need into it, right? It's going to be super powerful, especially if it's being used for just one thing. And that's how you might see it in real life, right? If a hobbyist has created something or a company is using a Raspberry Pi for something, it's going to be on the higher end, the 8 gigabyte, and it's going to be running all the time. So some of the things that I've seen are you can actually put a local ad blocker and cookie like trawling. So when something is going through your computer and trying to get your information, for example, Google Chrome, I use it all the time. It absolutely gets its claws into your computer and it slows it down by accident, but what it's really trying to do is get your information, and that's how we're paying Google, right? Is by giving them our data. You can actually set up a Raspberry Pi that will prevent that from happening for any of your devices on your network at home.
That's
right?
kind of cool.
So,
So great teaching cybersecurity then.
absolutely,
right?
you're protecting your family, right? So I don't know how many kids, but if I did, I might be thinking, how do I protect them from this, exactly, the cyber front. Other stuff, you can set up the sensors. So I mentioned it with, with microbits, but you can also do it with the Raspberry Pi, moisture detection. So on top of that, you can also hook up a servo to it. So you could set up a watering can, if you'd like, next to a plant and put the moisture detection in the plant. And then when there's a certain soil moisture level, it's going to use the servo to tilt over the can and water for a bit and then go back over.
That's
right?
cool too. And again, so as you can imagine, hopefully your brains are thinking, oh wow, that's cool. What else can I do? And so where can you find out more? You can Google YouTube videos, go to Raspberry Pi. I think they have their own website,
Yeah,
right?
I think it's raspberrypi.org.
Yep.
Again, YouTube, documentation, there's a lot of documentation, and that's a good thing. You may not like to hear documentation, but it's where people have tried stuff and they've written down the specific steps that got them from point A to point B. We followed documentation to get this set up here today, and I would always follow documentation going forwards, right? It's a good practice as a developer.
Yeah, and teaching students to do that, right? To follow that. Otherwise, they'll get lost and frustrated. So learning about the technology and how it can be used is really beneficial for them, because in the future they might have to experience something similar to it. So transferable skills, definitely. All right. So what are we doing here?
Yeah. So what we've got set up here is our Raspberry Pi. It's got its Ethernet wire plugged in and the USB-C for power. So the Ethernet is allowing me to control the Raspberry Pi itself. Like, it has a couple of programs on it, and I just need to tell it, hey, can you run these programs, right?
So we're communicating it via IP.
Exactly. So I've actually SSH'd in on my computer to then tell the Raspberry Pi what to do. If you wanted, you could plug a keyboard and a monitor and a mouse, probably back in the USBs, directly into the Raspberry Pi, and it out of the box usually comes with a graphical user interface. So what you would see on a computer when you turn it on, that's the graphical user interface when it's got something showing up on the screen. The Raspberry Pi acts like a computer and has the same thing. That's not the way we're doing it today. We're using our computer to SSH in and then tell it to run a program that exists. What's going on here is it's already receiving power, so one of the lights is just running right off the bat. And then what we're going to do is go ahead and go to the computer and just say, hey, can you run this program that'll make the yellow light flash?
And the point here is trying to show educators how you can integrate coding and different languages with some device like this and interacting. It's really software, hardware working together.
Yeah, so I'm just typing Python and then the name of the file, and I'm hitting enter, and we can see the yellow light starts flashing, right?
Yeah, so Python. Why Python?
Why Python? So
hardware
versus
Python,
software.
right?
This is where you're crossing over, right? So traditionally, you're getting experience with one or the other, right? You're a mechanic, or you're you're a software engineer. You're a physical engineer, like you could be aeronautical engineer, versus, again, software engineer. It's a very broad. A software engineer would be like saying just engineer, right? Physical engineer. So why Python? So Python is a really simple language that's very easy to read. It's super similar to an existing language, JavaScript. So that's also helpful because you can transfer your skills between the two of them very quickly.
And one of the most popular used with hardware, right?
Yeah, Python. So Python is very popular with hardware and data science or analytics. So those are two of the fastest growing fields. IoT, right? So hardware, and then also analytics, data science, machine learning. That's all stuff that integrates very nicely with Python as a language.
So let's talk about Nebula Academy for a minute and how we do the training with our students. So when we're teaching full stack web developers, we're really introducing them to JavaScript and we do that first. So we teach JavaScript first, and then HTML and CSS, and we have our own method to our madness and why we do that, which we won't get into today. But and then what we find is our students are curious about Python when they graduate, and it's great because that's what we want to create. We want to create that curiosity so that they can go out and they're armed with independent learning, that they know how to pick up a new language on their own because we've taught them how to do that. And that's really the benefit here. And we see a lot of our graduates going, I want to learn Python now, which is awesome. We want them to do that, right? So in schools, we'll hear from educators all the time. Well, what should I be teaching my kids? Should I be teaching them Python? Should I be teaching them JavaScript? What should I be teaching them? And so, you've got to decide. A lot of variables play into that. First of all, it's your background and experience, whether or not you can, which language you're better at. Right? And so you might want to start with something that you understand and know, or something that's simpler for you to pick up. And then maybe progress to Python. But we have some educators who go right into the Python. And so I think it's all a personal preference and your own capabilities.
Yeah. As you said, it comes down to personal preference. So for myself, I do prefer JavaScript because it hooks right into HTML and CSS.
For web development,
which gives us that visualization of whatever you're putting together on the logic side, on the JavaScript side. For Python, you can actually do web development as well.
Yep.
There's just an extra step or two in between getting it to communicate with HTML and CSS. But again, with hardware, and this is why most students are learning Python first, because they're joining an engineering team, they're coding the drones, that sort of thing, and they're getting introduced to Python right off the bat, combined with the fact that the syntax, or the way the language is written, is super clean and doesn't have a lot of the braces, the end of line syntax. It's very nice and simple.
All right, so cool. So we've shown you a real simple piece here. What we're doing here today is just exposure. We want to make sure that you come back and watch future sessions with us and learn more about how you can use the Raspberry Pi in your education sessions or in your own personal learning. So thanks, Nick, for joining us again here. Anything else you want to share with the folks before we go?
I think it's just same as everything else. It's super fun. If you are inclined towards technology and your students are inclined towards it, you're going to teach them faster and you're going to teach them more.
Thank you for joining us and learning about how we can use the Raspberry Pi in education. Join us again next week, where we'll come back and show you some more tech and get really fun in using the technology. And then if you are interested in learning more about us, go to nebulaacademy.com. If you are interested in joining some of our younger adult programs or a teacher volunteering, please go to weconnectthedots.org and help us out, make a donation to help us support students from underrepresented populations learning these innovative experiences. Thank you.